Good day, my dear learners, and welcome to today's lesson. Today, we are going to still look at particle model, but we are going to look at what? A different aspect of a particle model. Previously, we have looked at particle model for solids, liquids, and gases. We also looked at what? Diffusion. Yesterday, we looked at heating. So today, we are going to look at what? Cooling. So yesterday we said when you are heating, you add energy. And what kind of energy do we add? We add what? Heat energy. All right, so let's get going. All right, so we are looking at what? Change of state and then cooling. All right, you remember yesterday we were looking at change of state, but heating. What happens? Now, by the end of the lesson, you should be able to describe what happens when a gas or liquid is cooled. Explain condensation in terms of the particle model of matter, and explain freezing or solidification in terms of what the particle model of matter. All right, now, so what is needed for a substance to melt? Remember yesterday, we said the substance must be heated and energy has to be added. So when we are heating, we are adding the energy. Now let's look at the change of state, which is cooling that we are talking about. When a substance is cooled, what it means is that heat is taken away and the temperature of the substance what decreases. When a gas is cooled, it changes to what? To the liquid state. And we call it what? The process condensation. Now the particles of the gas lose energy. They move less energetically and closer to each other. And when a liquid is cooled, it changes to a solid state. We call this change of state freezing or solidification. Now the liquid particles lose energy and move even closer together until they only vibrate in one place. Now the amount of matter stays the same during a change in state and the particles do not change. What does this statement mean? I'm going to repeat it. It says the amount of substance stays the same during a change in state and the particles do not change. So for instance, if I have a cup of water, I put it in the fridge, and then what it becomes what? It becomes solid. It freezes and is now in solid form. Then the same cup of water, I bring it out, leave it out in the open, and then what happens? It will absorb the sun energy and start what? Changing state. Now, it's the same quantity that is in the cup. So when I bring it out and then it's changing state, it's still the same quantity of water. And the particles of the water do not change. It meaning it doesn't change from water to something else. Yes, that's basically what the point is saying. The amount of matter stays the same during a change in state, and the particles do not change. All right. Now, this is basically what happens. So, if we have a gas and energy is removed, it becomes what? Liquid. Now, if we go further and energy is removed, it becomes solid. Now, the process of a gas moving to liquid is known as what? Condensation. And then the process of what? Liquid going to solid or changing to solid is known as what? Freezing or solidification. All right. Now let's continue. Have you noticed this? Sometimes if we have if we take out a cold drink bottle, mostly a can or even a bottle, then we place it outside. After some time, you see droplets of water that are on the outside of the cold can of Coke, or for example. Do you know what happens, my dear learners? So what happens if I bring out a cold drink bottle or a can of cold drink from the fridge and I leave it outside the fridge? After some time, you have what? Little droplets of water on the side walls or outside of it. What is making that so? Where do these droplets come from? Do you have any answer? Yes, my dear learners. Okay. I'm asking a question. If you take out a cold drink can from the fridge and you place it outside, after some time you will observe little droplets of water on the walls of it. Where is or where do these droplets come from? No, when not, you don't even open it, you just leave it. Yeah, but yeah, it was in the fridge and it is cold. No, I'm not talking about shaking to open. No, I just took it out from the fridge. It's cold. Then I leave it outside. And then I observe. After some time, I see droplets, droplets of water on the side, outside of the bottle or the can. Yes, I'm not even opening it yet. Somebody is saying it's melted. You are still not getting me. Yeah, you are giving me the answer, but you are not getting the right answer. Okay, somebody is getting closer, and Tlantla is getting closer. Most of the water droplets. What about the water droplets? Yes. Tell me, where do we get the water droplet? And Tlantla, is the can having a moisture? Okay, let me give you a hint. Look at in terms of these this object. There are two objects or systems there. That cold water bottle from the fridge and then the surroundings. So don't look at that bottle in isolation. It's outside in the surroundings or in the environment. So what is happening? And then we are getting the what? Those little droplets of water. I've given you a clue or a hint. I hope you are going to get it. Yes. Make it fast and snappy. I know you are busy typing. I'm waiting for you. All right. Okay. Now listen. Okay. Now listen. The answer is right here. Where do these droplets come from? The answer, water vapor in the air condenses and forms liquid water droplets on the scan. You see, so the cold drink bottle is from the fridge, so it's very cold. Now, so it is having a different temperature compared to the what environment. So in the environment, we have what? Water vapor, that is water in the gas state. It's a bit, the temperature is different from the what? Cold drink bottle. So when they settle, when the water vapor in the environment or in the atmosphere settles on your cold drink bottle, then the droplets are formed on the can. That's what I was trying to let you get. Okay. Now, so let's you now understand. Now, what happens when the gas particles of water in the air come into contact with the cold Coke can? They lose energy. The particles have less kinetic energy, so they move slowly. They move more slowly. This means that the forces of attraction are able to pull them closer together. The spaces between them decrease, and eventually the particles touch and form a liquid. The particles are still able to move freely. Should we put the can of Coke in the freezer? The water droplets will what? Freeze again. In the freezer, the particles lose energy and have less energy to move. So the forces of attraction pull them closer. So you see what happens? Yes, so the more we take energy, then the more there is a change of shape. If it is a gas and we take energy, it goes to liquid. So if there is still energy there, we take the energy, then it goes to what? Solid, or it freezes. So cooling is the opposite of heating, in which we have to add what? Energy. All right. I hope we are following. Okay, let's move to the next. Now, so we're continuing from the together, they settle into a fixed pattern. The particles can no longer move past each other, so they vibrate in what? Fixed positions. The spaces between the particles decrease until they are packed close together in a solid. Very good. The water particles did not change during the change of shape. The particles of water are the same as the liquid particles of water, and are also the same as the solid particles of water. I hope you get that. So the particles in the liquid are the same as the particles in the solids. All right. Now, taking heat away from a substance can cause the substance to change state. When heat is taken away from a gas, it condenses to form a liquid. I just mentioned that. The gas particles have less energy and move closer to the other particles until they touch and form a liquid. If we cool a liquid, it will change to a solid state. We call this process freezing or solidification. The liquid particles lose more energy and move even closer to each other. This happens to the point where the particles are so close together that they cannot move freely anymore. They remain in one place and are only able to vibrate. The amount of a substance remains the same during a state change, and the particles do not change. Fantastic. Is there any question here? Send in your question. If you don't have any question, I have a question for you. All right. Let me see this. Okay, now I have a question for you. All right. So, what happens to the amount of substance when I put a cup of water in a fridge and it turns to solid? What happens to the amount of substance or amount of the liquid that I put in the fridge? What happens to it? Yes. What happens? Yeah, let me see. There is an answer coming in. Okay, somebody says it increases. I'm waiting for other answers. All right. Somebody says the particles come closer. I'm saying the amount of substance. The amount of substance. Yeah, send in your answers. Okay, I'm saying what happens to the amount of substance. All what you are saying, you are right, but what is the amount of substance? What is happening? What is happening to it? Okay, the amount of substance do not change. That's good, Teresa. Perfect. All right, let's move to the next. Okay, so I move away from this slide because it's still the same. The amount of a substance remains the same during a state change, and the particles do not change. Perfect. All right, now This is a checkpoint one for you. What do we call the process where water droplets form on the outside of a cold can of Coke? You write your answer. What change of state will happen when a liquid is put in it? Yes. Write your answers, let them come in. All right, somebody saying condensation, condensation. All right, let's see whether you are right. Let's wait for the other answers to come in. Somebody saying, okay, since it's private, I won't mention it out. All right, so let me read it again. We're talking about what do we call the process where water droplets form on the outside of a cold can of Coke? And what change of state will happen when a liquid is put in it? When a liquid is put in it. All right, send in your answers. All right. Okay, most of you are getting it right. Let's go to B. All right, let's go to B. Waiting. Let's go to B. Let's go to B. We are referring to A. What change of state will happen when a liquid is put in the, what do we call the process where water droplets form on the outside of a cold can of Coke? And what change of state will happen when a liquid is put in it? Maybe referring to the Coke. Or is that question is confusing you because the way it is? All right, let me show you. Okay, so this your correction. You all got it. The first one was what? Oh, yeah. I think something was missing out there. Thanks very much. Somebody asked a very good question. In the question, yeah, they said you are correct. Something is missing there. So you see the whole question. When it's put in a freezer, what change of state will happen when a liquid is put in a freezer? So most of you got a correct, condensation, and then this one is my fault. It's like the question was not finished. All right, I didn't edit my writing very well. Okay, so the liquid will change to a solid. Very good. Now let's go to another assessment. Okay, so in fact, yeah, is this one also is the same thing. All right, it will change to solid. Now let's go to this. All right, this one, I edited it well. So you what when a solid is heated is what you fill in the what the gaps. So you copy this, or you just give me the answers. But I wish you can write it or take a shot of it in your what and keep it as a record. So when a solid is heated, comma, it dash increases and a dash. The solid changes to a dash When a liquid is a dash, its energy decreases and it dash. The liquid changes to a dash, and a dash changes to a liquid when it is cooled. This is called dash. The energy of the particles, you fill in the gap there. During evaporation, you fill in the gap, changes to, you fill the gap as the temperature is, you fill the gap. The energy of the particles, you then fill in the what? The gap. Okay, I can see somebody. Very good, just right. So yeah, it freezes. That's good. So now you fill in the gap. How many gaps do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 13 box empty spaces, 1 for 1 each, 1 for 1 mark. So let's see. Okay, send in your questions if you have. Yes, send in your answers. I know you are typing now. Okay, I know you are typing. All right, let's keep going. I know you are typing now. Let's get going. All right. Okay, just we have got 13. So I want to see who will get the highest score. There are 13 spaces to fill up. So for 13 marks. So I want to see the one who will do that. Yes, let's continue. Okay. All right, let's continue. You're supposed to get 13 answers. If you can manage to do that, okay, let's go on. Keep your answers flowing in. Yes, keep your answers flowing in. Okay, I can see somebody. All right, Natalie. I like the way, Natalie, you have done it. You have incorporated everything. Yeah. All right. But some of you, you are putting it in bits, in bits, in bits. I wonder if you will be able to follow the scoring. Okay. Let's continue. Yes, I can see Teja also coming in with the answers as well as Lisan. All right, let's keep going. Send in your answers. In the next few minutes, two or so, I will be sharing the memo with you or the corrections I want to say. Okay, let's keep going. Let's keep pushing. Let's keep pushing. All right. All right. If we can get total, I will make sure that I give you a present. I will give you a Kahoot present. All right. Musa answer is also coming in. Let's keep pushing. Okay. Musa, you are almost there as well as Lisan. Okay, let me see the, hey, that's good. Somebody also, all right, let's say the, you also send in, yeah, I like it this way. You can see your answers. Yes. Okay. 1 minute more for me to go to the next for corrections. Sorry. For me to go for corrections. All right. Okay. Are you ready? I'm going to the corrections since we are working with time. Who is going to get total? Let me see by hands here. Those who think they will get total. Let me see by hands. Okay. I can see Natalie. Natalie raised up their hand. Okay. Who is going to get total? In addition to, okay, let's say D. All right. So let's go. We're going to show. All right. These are our answers. So check and mark. When a solid is heated, its energy increases and it melts. So that's 2 marks. The solid changes to a liquid, that's 3 marks. When a liquid is cooled, its energy decreases and it solidifies or freezes. The liquid changes to a solid. A gas changes to a liquid when it is cooled. This is called condensation. The energy of the particles decreases. During evaporation, a liquid changes to a gas. As the temperature is increased, the energy of the particles increases. Yes, so mark and tell me who got 13 out of 13. And you must be fair as much as you can. Let's get going. So our proposed answer to the tasks in the previous lesson. All right. Are you still busy marking? I want to know the one who got total there. Okay. You said you got out of what? It's out of 13. Lucy, that's good. Natalie, that's good. Congratulations to both of you. You have done well. Also, Teresa, congratulations. Okay. We have to move to the next slide. Or people are still marking, they should mark and tell us what they got privately. So if you don't want to make it public or to everyone, I'm not going to read it out because it's private. I'll just acknowledge you. Okay, let's keep moving. Let's keep moving. All right, we go to the next. Oh, no, I'm not going to laugh. Listen, there is always room for improvement. I like your kindness. I will support you to make sure that you are fine. Okay? And who again? And who again? Mark and just send me a private message of what you got. Don't put it on public so that everyone can see your marks, just to me alone. Okay. Let's go to the next. All right. I hope you have taken a snapshot of this, or you have written it down for reference. All right. Let's go to the next. If you want Kahoot, then we should do Kahoot. I should go back. Okay, just a moment. Let me go back for Musa. Yes, I'm back here. Musa, I'm back for you. Are you referring to this place? All right. Musa, when you are done, you let me know. Okay. All right. Good. All right. Okay, so we are going to Kahoot and we are going to play the same game yesterday. And those of you who didn't participate, I want you to participate so that you have a feel. I always see Lisan, I want you to play today. I don't always see Lisan unless otherwise you have a nickname that I don't know. So Lisan, I want to see you log in. Thursday is also there. And Mosa, I know once a while you are also there. So those of you who are not always participating, I want you to participate. Eh, Oh, you are Catleho. Okay. All right, I see. Okay. All right. So let's do this again. So we are left with 5 minutes. I hope. So this is our last Kahoot we are playing for this topic. The next we're going to, so I'm gonna share. I'm sharing. It's a bit slow. Yes. Okay, so we are here. Let's go for it. So this we are playing it for the third time, and yeah, you wait for the pin. There comes the pin. Are we ready to go to join? Yeah. Okay, it's 37 66 37 66 06. 37 66 06. Let's join. I have four players. Katlewo is here, Lisedi is here, Han Tlantlan, Natalie. Okay, we have what? 3 minutes. So let me just start playing now. Let's start playing now. Okay. I hope we will finish. You 20. Let's go. Maybe we will be lost on the way because of the time. So make it fast. Some of them I will skip them. All right, correct. Let's go to the next. Let's go to the next. The change of state from a solid, from a gas to a liquid is, that's correct. We already learned that. Okay, let's go fast. Terrain. That is a change of state from solid to gas. Let's get going. All right, forgot this one, right? Let's go. Very good. Let's go to the next. Next. To the next. 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 Diffusing perfect. Let's go. H is time. All right, guys, it's time. I hope we will finish next time. But as you can see the scoreboard, okay, let's do the next one and we'll see. Oh, we are going to do 10 questions, so two more. And then half of 20 is 10. So we'll see the one after 10. All right, let's go. All right, number 10. So let's see. Last one. The liquid can change its shape. Fast, fast, fast to answer to see. Very good. All of you got it. Let's see. Ooh. Okay. So at the end of 10 rounds, you see, we have got the scores on board. It was nice having you. We will complete this game next time. Bye and have a what? A nice day. Okay.